Okay, good morning students. So today we are going with question number 2. So yesterday we did question number 1 where the equation was given, then from that equation we have calculated vertex, focus, equation of directrix and all the elements of the parabola. So now today is a little bit different compared to yesterday. Today we are going to find the equation of the parabola from the given condition. So under question number 2, here the vertex is given at the origin, but in question number 3, which is in the next video, I will show you where the vertex is not at the origin and you need to calculate the equation of the parabola. So this case, under this we have 3 questions. I'm going to solve 3 questions. One at directrix at x is equal to 5. Second one, directrix at y equal to -7. And then this third one passing through -3,7 and x is along the x-axis. So after finishing with this one, then make sure you do this homework. In our textbook we have, go to chapter 12, page number 13, exercise 12a. If you understand this concept, you will be able to solve these 3 questions. There's question number 1, question number 2 and question number 6. Make sure you do this homework and then check yourself whether you have understood this concept or not. So without wasting time, so let's directly start with question number 1, where the directrix is given at x is equivalent to 5. So number 1 we have directrix at x is equivalent to 5. Then next one we will go directrix at y equal to -7. Then next question. So let's start solving this question now. Directrix at x is equal to 5. Now, please remember the vertex is in a question clearly mentioned the vertex is at the origin and the directrix is at x is equal to 5. Now, please check your understanding. Is this concave right, left, up or down? I'll give you 1 second. Please think it over. Is this concave right, left, up or down? Remember, vertex is at the origin and directrix is at x is equal to 5. This is concave, left. This is concave left. Here, because the directrix is given at x is equal to 5. So let me take this one as directrix. Directrix is passing through at x is equal to 5. And then say this is directrix D dash. And the vertex is given at the origin because in question clearly mentioned here. Question clearly stated that directrix is at x vertex is at the origin. So definitely this becomes concave left. That's why in first video session I have explained about concave right, left and this one. So you need to get thorough. Looking at the question you should know whether it's a concave right or left or up or down. It will be much easier. Directrix at x is equal to 5. Or you can write this one as a x minus 5 is equal to 0. Then definitely this becomes concave left. So if directrix is at x is equal to 5, where will be the focus now? Where will be the focus? Think it over. I will give you 1 second. So vertex, not vertex, focus will be at -5, where focus point will be -5, 0. Because I have clearly mentioned that from vertex to directrix and vertex to focus, the distance should be always equal. Why the distance should be equal? Because the eccentricity value is equivalent to 1 in case of parabola. If it is not equal, eccentricity value might be less than 1 or maybe greater than 1, which will become ellipse or either it will become hyperbola. So this case distance is always equal. So in order to calculate this equation of the parabola, what I can do here it is, let me take one point on the parabola, say this point P of x, y. Join these 2 points here S to P. Then from P, make sure you join to the directrix. Say, make sure the angle should be 90 degree. Don't forget, here the angle should be 90 degree. If the angle is not 90 degree, then distance of SP and MP will not be equal. This SP and this MP will not be equal. So therefore, here the angle made should be 90 degree. So now, as per the definition of parabola, eccentricity here it is modulus of SP divided by modulus of MP. Here we need to put modulus because SP is a distance. MP also is a distance. SP is a distance between 2 points. MP is a distance made by the directrix. So distance should not be in a negative. If the distance comes in negative, then with the help of this modulus, it will change it to positive, because modulus of -2 is equivalent to +2. Therefore, now you know the eccentricity value for parabola is equivalent to 1, which implies I can bring this MP here. Modulus of SP is equal to modulus of MP. This becomes the definition of the parabola. Definition of the parabola. So what's a SP? SP is a distance between 2 points. Distance between 2 points. SP, distance between 2 points. In class 11, there's a geometry, 2-dimensional geometry. What's the form of distance between 2 points? It is root of x2 minus x1 whole square plus y2 minus y1 whole square. This is for 2 dimensions. For 3 dimensions we have plus z2 minus z1 whole square. Then MP is a perpendicular distance made by this directrix. So we have modulus of ax plus by plus c divided by root of a square plus b square, where a is the coefficient of x, b is the coefficient of y. Therefore, SP is the distance between 2 points. Please join x to this 5. So we have square root of x minus of this minus 5 becomes plus 5 whole square. Remember, here x minus of minus 5, because as for formula we have x2 minus x1. Take this one as a x1 y1. Take this one as a x2 y2. Whichever you like, no problem. Either you take minus 5 minus x, no problem. So x minus of minus 5 becomes plus 5. Then we have y minus, please join these 2 points, y minus 0, 0 no need, which is y squared is equal to, and the perpendicular distance is made by the directrix. So we have modulus of equation of directrix. Please substitute the equation of directrix divided by root of, what's the coefficient x here? 1. It becomes 1 square. 1 square is 1 only. Square root of 1 is also 1. Let me square on both sides. Just to remove this root, squaring on both sides, we have x plus 5 whole square plus y square is equal to x minus 5 whole square. Square on both sides. The expand it, please. This is in the form of a plus b whole square. A square plus 10x plus 25 plus y square, and this side we have is a minus b whole square. I hope you know that expansion. So we have x square minus 10x plus 25. This x square will get cancelled. Then 25 will get cancelled. Finally, we have y square is equal to, take 10x that side, it becomes negative 20x, which is a required equation of the parabola. So if you get y square is equal to plus 20x, then it does not make sense, because y square is equal to 20x is a equation of concave right, but y square negative 20x is the equation of concave left. So our answer is correct. Y square is equal to negative 20x. Or I'll show you one shortcut. That is, or you can write this way in simple method, okay? You know the focus point. Every time it will not work. This case it will work because the vertex and is very simple here. You know this is concave left. So for concave left, what's the standard equation of concave left? Y square is negative 4ax. Remember, this is a concave left. So which is equivalent to negative 4 times, what's the value of a? What's the value of a? You know this focus is negative a comma 0. What is the value of a? Value of a is 5. Not negative 5. Negative, but the value of a is 5. Substitute 5 here. 10 times x. which is equal to negative 20x. Is this two same now? Isn't it? So this also is one method to solve. You can either use this method or this method. But this method, especially you can use under MCQ. But for section B, I think it will be better you go with this method, because from here onwards, we are going to follow this method. So thank you. In next video session, we'll do question number 2, Roman number 2. Thank you.